Kamu ada few main things yang kamu kena tahu. Number one, you need to know the formula. Ada 2 formula. Okay, lepas tu kamu kena boleh melukis dengan able to solve the problems related to the topic. Okay, we start with the formula first. So kalau kamu ingat, sesi lepas, kita ada apa tu? Acceleration, which is gravitational field strength. Sekarang dia lebih kurang juga. Kita panggil sekarang electric field. Kalau topik dia sebenarnya electric field tapi saya tambah strength kat sini. Sebab biasanya dalam exam memang dia sebut perkataan strength tu. Dan bila dia sebut strength tu, student dia teringat itu adalah force. Tapi bukan dia sebenarnya adalah E, electric field. Okay, so if you want to compare with the previous one, we have F equals to ma. Okay, where A here is the acceleration ataupun dia punya, kalau dulu gravitational field strength, ini adalah G lah, gravitational field strength. Then you can rearrange, dia jadi A equals to F over M. But in this topic, we have something quite similar. Yesterday we learned about force, which is equals to Q naught E. So yang Q ni ibarat dia punya mass lah. So identity untuk sesuatu objek tu, macam kalau objek tu physical, the mass tu melambangkan dia punya objek tu. Tapi charge ni kamu bayangkan lah, the charge punya quantity itu adalah dia punya identity. Yang E ni dia punya strength dia. So if I rearrange E, it will be F over Q naught. So electric field strength indicates dia punya kekuatan medan magnet tu. You can see that the unit will be Newton per Coulomb because of this one. Force in Newton, charge in Coulomb, so it will be Newton per Coulomb lah. Then if I substitute yang semalam punya formula, E will be equals to F over F tu sama dengan KQQ over R square. Okay, over Q naught. Okay, yang Q naught ni sebenarnya adalah test charge. This is a test charge. Okay. By default, we assume that the test charge is positive. Melainkan diberitahu lah. So test charge ni dia macam charge yang olok-olok. Dia just letak untuk berandaikan something. Mungkin kamu tak nampak sangat kot. Tapi dia just olok-olok lah. So that means salah satu daripada sini, charge dia ni, yang tadi F tu kan, daripada test charge itself. So you can cancel out this one. You left with E sama dengan KQ. Okay, right over here. KQ over R square. Okay, if I want to find E1, that means I have to use Q1. Itu maksud dia lah. So the two main formula that you'll be using in this chapter is, the most important one is this one lah. Okay, the second one would be this one. Yang second one tu kita jarang sikit pakai, tapi boleh jadi dia suruh kira lah. Yang second one, yang this one ni, kalau dia suruh kira, biasanya dia suruh kira electric field dulu. Cari electric field dekat point P. Lepas tu dia kata, katakanlah ada charge diletak kat situ. So berapakah force dia? And then you can use this formula. Or else alternatively, you can use yesterday punya lesson untuk cari dia punya force. Okay, so far ada soalan ke tidak? Can you guys?
Tak ada, sir.
Tak ada Okay. So this one is just introduction lah. And then please remember that this one is still a vector quantity. E is a vector. So E, is a vector. Okay, which means that for the formula, you don't have to substitute the negative inside the formula. So the negative or positive charge tu kamu use untuk tentukan direction of E. Tapi dalam calculation you don't have to include the sign. Okay, the next part you have to be able to draw lah. So actually drawing tu ada dalam buku nota. I just show you the important one. Let's say if I have a positive charge and negative charge. Let's say this is a two separate world lah. So this is isolated case. Dia tak ada kaitan pun antara kiri kanan tu. Okay. So kamu ada charge. This is dia punya field. Kamu dah baca kan? Kalau positif, electric field tu into ke radially outwards? Adakah masuk towards charge ataupun keluar daripada charge?
Outward.
Outwards keluar. Kalau negatif, dia masuk. Okay, very good. So itu kamu kena hafal lah. There's no choice. Okay. Okay. So ini keluar. Ini masuk. Okay, we call the direction tu as radially outwards. Radial tu maksudnya secara membulat macam tu lah. Radially outward. And this one radially inward. Okay, dalam exam melainkan disuruh lukis, then only you have to draw something like this. Most of the time kamu just nak cari dekat certain point je, so you don't have to exactly draw like this lah, melainkan disuruh. Okay, katakanlah kalau case lain kamu ada interaction between charges. Let's say if you have dalam nota kamu sebenarnya ada tapi dia letak positif. So let's try negatif. Okay, cuba kita tengok. Kalau kita ada dua negatif, katakan dia punya magnitude is equal, Q and Q. Okay. Kalau magnitude dia tak equal, ada beza lah. Then I would expect to have field like this. Oops. Degil Okay. Okay, so the line is actually masih lagi into the charge, just that dia ada reflection tu, macam apa tu? Bend. Sebab apa? Sebab you will expect dia akan tolak each other kan? Repel. Okay, ini adalah contoh lukisan. So you need to be able to draw lah. Sama ada dia kasih dekat UPS ke, dekat final ke, I really don't know. Yang the remaining one, you can always check dekat lecture notes. Page 6. Okay, can you guys follow? Ada masalah tak?
Yes, sir.
Boleh.
Okay, good. Now, moving on to the next part. Macam saya beritahu lah, nak lukis ni melainkan disuruh lukis baru kamu lukis. Most of the time, you just want to determine at certain point. Dekat sesuatu point tu, berapa nilai electric field, direction electric field tu ke mana, and so on. Okay, I try to take an example. Let's say if I have a negative charge. Abaikan ombak-ombak itu. Okay. So you have charge dekat situ. And then dia kata dekat sini ada satu point over here is what we call point X. Dekat point X ni, direction of electric field dia ke mana? Soalan ni biasa macam tu lah. So, macam mana nak tentukan? The easiest way is that you know that all of this electric field, semua-semua ni, towards the negative charge tu. So, kalau saya panjangkan, kan, by logic, it will be in that direction. So, tapi kita tak nak lukis macam tu. Kita just nak focus on point X tu saja. So, you will expect the direction to be like this. Faham tak? Okay. So, kalau the positive charge, katakan yang ini adalah positif, you expect it will be like this. Contoh. So, macam saya cakap lah, you don't actually have to draw yang line-line ni. Okay. You just want to focus at this point, direction of electric field tu ke mana. So previously, I told you about a test charge. So test charge ni, bila dia lukis electric field, they assume that the test charge is positive. So they assume kat sini ada positive. And you can see that this is the direction lah. Dikatakanlah test charge tu bukannya positif. Katakan dia letak sebagai negatif. Okay, katakan dia masukkan nilai. Okay, masukkan nilai negatif. So direction of force yang electric field dia masih samalah. Kalau force pula, kalau electric field dia macam tu, charge dia adalah negatif, so it will be in opposite direction. This is a fact. Okay, ataupun kamu boleh apply yang knowledge before this. This is equal charge, equal punya polarity, so dia akan repel. So this is the direction F. Kalau saya letak dia sebagai positif, okay, so you will expect the F will be in the same direction dengan E dia. Okay, so again, this one masa bila kamu nak apply, bila kamu ada, kamu dah disuruh kira electric field, and then suddenly dia kata find the force, net force dekat point X kalau tiba-tiba dia letakkan charge positif ataupun charge negatif. Okay, nak tahu faham ke tidak, cuba kita buat soalan. Okay, cuba kamu buat soalan tutorial page 20, soalan nombor 8, A dengan B. Okay, cara nak selesaikan actually sama exactly macam semalam. Method dia kan step by step exactly the same. Just that instead of F, saya tukar dia kepada E. Okay, and then you can see that there's two charge, Q1 and Q2. And then ada point P. Okay, Q1, Q2 and point P. They want you to find electric field dekat point P tu. Okay, cara nak selesaikan dia sama macam semalam. Number one, you need to be able to draw the direction of E. Okay, ada berapa banyak E dekat sini sekarang? Electric field ada berapa banyak? Dua, okay, very good, Nadir. Okay, sebab apa ada dua? Sebab kamu ada dua charge, okay. So you can see that over here, setiap satu ni dia produce lah. Satu ni keluar, macam tu kan. Dan satu tu lagi masuk. So basically you have two charge, so two electric field. Macam mana nak tentukan direction tu? Kamu tutup satu, kamu tengok lagi satu. Okay, contoh if I remove this one, and then you just focus on these two. So kamu ada satu charge yang kat point ni. Okay, you know that charge ni dia produce electric field keluar macam tu kan. So kalau dekat point P tu, dekat this point, so if I panjangkan dia punya electric field macam tu. You see that? So dekat point P tu, kamu rasalah direction dia ke mana? Atas, bawah, kiri, kanan. Electric field.
Kanan.
Ke kanan, okay, very good. Sebab apa? Sebab yang tadi yang positif tu dekat daripada Q1 tu dia produce keluar. So dekat point P tu saja dia ke kanan. Macam mana nak tentukan? Macam tadilah. Kamu boleh try panjangkan. Okay, maybe tak praktikal sangat kan. Tapi that's the easiest way. Alternatively, ada banyak cara lah. Tapi kalau kamu dah biasa buat, kamu nampak straight away kot. Okay, now let's see if I want to do the second one. I'm going to put it over here again. I'm going to take this one out. Okay, now, electric field due to this charge. Dekat point P ni, direction dia ke mana?
Ke arah Q2.
Ke kiri.
Yes, correct. Very good. So it will be towards the Q2, which is to the left. This is your E2. Okay, once you get this picture, then it shouldn't be a problem. Okay, kalau kamu dah dapat dia punya yang point P tu, sepatutnya tak ada masalah. Okay, just try to redraw over here. This is point P. You have E1 and E2. Buat apa nak lukis balik? Tak apalah. Okay. Now the next step, step number 2, you have to calculate the individual E. So saya cakap, at least kalau dapat soalan, kamu boleh kira yang step 2 ni. At least kamu dapat about 60% of the marks. Okay, to calculate individual, so you have to do separate, E1 and E2. Again, you can do this one inside a table if you want to. Tak masalah. KQ over R square. KQ over R square. Since this one is 1, dia 1 lah. This is 2, 2. K dia sama je nilai dia. Okay, Q1 tadi kita tengok balik. Q1 adalah 6 microcoulomb. The distance from this point up until point P is 3 plus 4. It will be 7 centimeter. But you still have to convert to meter. So 0.07. Don't forget to take square. Okay. And then the second one, the charge will be 1.5, but it is much closer, 0.04. Then if you press your calculator, your E1, you should get 1.10 times 10 to the power of 7 Newton per coulomb. The second one, got 8.44 times 10 to the power of 6 Newton per coulomb. Dapat tak?
Sama sir.
Okay, very good. Okay, now yang step ni dia tak ada markah, but then if you write it will help lah. So direction dia ke mana? Nah, E1 tadi kita tulis balik, E1 tadi ke kanan, so to the right, and E2 is to the left. Okay, so you have two vector, satu ke kanan, satu ke kiri. So obviously, if you want to find the E net, E dekat point P sama dengan right minus left. So we assume that positive is to the right, negative is to the left, and if the final answer that we got is positive, it means that the final one would be to the right. If negative, it means it is to the left. So we're going to calculate that one. 1.10 times 10 to the power of 7 minus 8.44 times 10 to the power of 6. So my EP dekat point P tu, E net dia is apa ni? Two point five six times 10 to the power of 6 Newton coulomb. Sama ke tidak?
Sama sir.
Okay, direction dia to the Right. Sebab
To
apa?
the
Sebab
right.
dia positif. Yes, very good. Okay, senang tak? Senang ya. So yang tricky part dia sebenarnya yang ni je. Just that you have to determine the diagram correctly. Once you do that, and then shouldn't be a problem. Okay, that one is for question A. Go straight away to question B. Question B kata, if a 5 microcoulomb test charge is placed at point P, calculate the magnitude of the resultant force act on the test charge. Okay, so this is your point P. I'm going to take this one, copy. Oh, tak nak lah, saya ikut balik je lah. Dekat point P tadi, this is point P. E net dia to the right. Okay, if I were to put 5 microcoulomb, it's a positive sebab apa dia positif? Sebab dia tak cakap dia negatif. So sepatutnya dalam soalan tu kalau untuk nak cakap negatif, dia mesti cakap lah if a negative 5. So dia letak negatif tu, ataupun dia kata if a negatively charged particle with a magnitude of 5 microcoulomb, and then you can see that it is actually negative lah, tapi ini positif. So it's a positive, katakan saya letak positif kat sini. Oops. And the magnitude is 5 microcoulomb. Soalan dia, calculate the resultant force. Okay. Direction dia ke mana? Tadi saya ada tunjuk saya. Adakah ke kanan, ke kiri?
Ke kanan.
Yes. Sebab apa? F dekat P is to the right sebab yang charge kita letak tu adalah positif. Aku nak angkat tangan apa aku? Okey tak? Terima kasih.
Tekan saya.
Okay. So kalau dia positif, F dengan E tu sama direction. Kalau dia negatif, F dengan E tu opposite direction. So you have two methods nak selesaikan yang B ni. Number one, you can follow yesterday what you learned. And assume that you put a positively charged particle over here and then you calculate lah, ada dua F. F due to this one. And then F due to this one. Direction dia ke mana? F1, F2 ke mana? Cari F net. And then you can solve. Itu satu cara. Or alternatively, you can use this method. Iaitu kamu terus pakai formula yang ada. So like I told you before, E tadi sama dengan F over Q. Okay. So this is my Q naught lah. So my F is actually Q naught multiplied by E. We are talking about at point P, so kita boleh kira straight away. Direction pun kamu boleh tahu straight away based on charge yang diletak tu, charge positif ke charge negatif. Kalau tiba-tiba dia letak negatif, dia opposite daripada E yang kita dah kira tadi. So 5 times 10 to the power of negative 6 multiply with the answer we got just now, 2.56. And this one you get berapa ni? 5 exponent 6. 5 exponent negative 6. .8. Is it correct?
Yes, sir. Correct tu.
Correct. Try to check the answer. Okay, same answer. Okay, good. So direction dia to the right.